Okay, so we will continue where we ended. It's almost time. We only have around 10 minutes. So this is the relationship we used a while ago in the problem on the rocket engine. So we did not anymore solve separately the rate of consumption of oxygen or the disappearance of oxygen because we made use of the relationship available in the stoichiometric equation or in the chemical reaction. This particular principle class is fundamental for kinetics. So whether we're talking about elementary or non-elementary reactions, this particular fundamental relationship will have to hold true. So if you know already the rate of reaction in terms of A in here, then you have to use only the coefficients of A together with the species that you're going to correlate it with. So rate of reaction of A with respect to divided by A in the stoichiometric equation, B, and then you have C and you have D. I place here the negative because I did not place the negative rates of representation for A and B. We should be negative here in the first place because these two are disappearing or they are reactants. So this should be negative R sub A over A, negative R sub B over B is equal to, these are all equal to R sub C over C and R sub D over D. So in the case of this example of the combustion of nitrogen oxide forming nitrogen dioxide, so the rate of formation, in this case, the rate of consumption of nitrogen oxide divided by 2 is equated to the rate of consumption of oxygen divided by 1 equated to the rate of formation of nitrogen dioxide divided by 2. So these two are supposed to be negative again because these two are reacting species or they are reactants. So that's the rate law. Now, for example, so this is just but a self-test, you are required to write a rate law for this elementary liquid phase reaction. So take note, it says elementary liquid phase reaction. So the stoichiometric equation is 3A plus 2B forming 4C. Solely in the terms of the conversion, in terms of conversion, negative R sub A as a function of X. Now, this is class X is already conversion. And since I haven't yet started with conversion, we will just simply express the rate law in terms of concentration because I don't want to ask you something that I haven't yet discussed. X here is conversion. The feed to the batch reactor is equal molar A and B. So meaning equal ang moles of A and B that is being fed into the reactor with the initial concentration of A and B being equal to 2 moles per decimeter cube, and you are given this particular rate constant which is 0.01 decimeter cube per mole raised to 4 per second. Now, I think you know already why this one is raised to 4 per second, because if you notice, if this is an elementary reaction, the rate law will solely be based on the stoichiometric equation. So the requirement here is what is the rate law and what is the concentration of A and B at any time t. So for now, I will just simply write the representation of the concentration of A and B at any time t without us having to solve it specifically. We can solve this later on, or you can go back to this later on once I have already given you a way of expressing concentration at any time in terms of conversion. Conversion is letter X. Okay, so our goal here is to find the rate law. So I will have to share, we'll have to use the whiteboard again. For that particular example, let me check if I have already answered it. Let me see. Your rate law, I have already answered it, so there's no need for me to use the whiteboard, will be something like this. Okay? So your rate law will be the rate constant K times the concentrations of the reacting species raised to their corresponding coefficients in the provided chemical reaction or stoichiometric equation. chemical reaction or stoichiometric equation, they mean the same. Since the reaction is elementary, whatever is the coefficient of the species in your chemical reaction, that would be the exponent of the concentration term of that particular species. So we need to multiply the concentrations of A and B and rate it correspondingly to the coefficients of A and B in your stoichiometric equation. So this is already the rate law based on the statement that your provided reaction is elementary. Now, if it's a liquid phase reaction, you have to understand, and this is also very fundamental and a basic concept in kinetics, that if your reaction is liquid phase, there will be no change in the volume all throughout the reaction process. Meaning the volume initially of your species and after the reaction has already proceeded would be the same. So V final is equal to V initial or V original. V sub O is the initial volume. Now, that would be it. Wait. So in terms of what is required, what is the concentration of A and B at any time t? I'd like to answer this one. Okay, just a representation of the concentration of A and B at any time t. So I'll go to the board. The concentration of a reacting species at any time, let's say for example in the case of A, will be this. Ca is equal to CaO 1 minus Xa. This one class, although I will be going back to this in the integral analysis, is what we call, is representing the degree of conversion of A, this Xa. So at any time, so the question there in the problem is what is the concentration of A and B at any time t? So since the problem provides us with the initial concentration, let me see. So the initial concentration is 2 mole per decimeter cube. So we will use this particular value, but nonetheless, your x would still be x because we still did not have any value for x. So your Ca would be 2, 1 minus Xa. This Ca, this will be the same Ca that you will be seeing later on in our future discussion, will be the concentration of A at any time t. For you to be able to determine this concentration of A at any time t, there's a need for you, of course, to know the converted amount of A at that particular time. So we will just cross the bridge or discuss this Xa when the proper time comes. Okay, so this is your Ca. Your Cb, since it's equimolar, it reacted equimolar with A, so that would be still CBO, note 1 minus XB. What did I do? I just changed the representation here of CaO to CBO. In kinetics and in chemistry and in phychem, I'm sure that this one, you know already, represents the initial concentration of A, the initial concentration of B. This is now the conversion of B. This is the conversion of A. If you will have this expanded class, this would mean CBO minus CBO XB. Okay? In the same way that if this is expanded, this would be CaO minus CaO XE. And since you know already that your initial concentration is 2, you can substitute the 2 in here and the 2 in here. It's the same thing with CBO. Now, the CBO1 minus XB is the concentration of B at any time, just like Ca is equal to CaO minus Xa at any time, concentration of A. So I can place here 2, 1 minus XB. Or this could also be written as 2 minus CBO XB. Now, this could also be written as 2 minus CaO XA. So they have the same representation. They just change in this part. Now, let me explain what is this CaOXA and what is this CBOXB. If XA is the conversion of A at any time t, CAOXA represents the amount that was converted. Okay, CAOXA is the amount that was converted. Correspondingly, if XB is the conversion of B after time t or at any time t, then the CBOXB is the amount of B converted. Now, by the way, class, this XA and XB are expressed in terms of decimal. Like if XA is 0.7, this tells you that A is 70% converted. If XB, for example, is 0.2, it tells you that B is 20% converted at that particular time that is given in the problem. So now you have here a representation of CA and CB at any particular time t. So I like to, why is this? I like to have this as the representation, and I'll make it uniform, CB, and this will be for your CB. Now, and I like to end with this last part here. Now, you have the representation of CA and CB at any time t. These representations can be written as this also and this. From your stoichiometric equation, I'll go back to our slide. So this is our slide. In terms of the stoichiometric equation, so please recall this one, RA 3A plus 2B forming 4C. Okay, if I will not recall, so please remind me. 3A plus 2B is equal to 4C. Why is it very important? I'll show you something. If you're going to have the relationship of the parts that were converted, so you have CAOXA, that would be divided by a number. CBOXB, that would be divided by a number. And CCOXC, that would be divided by the number. What do you think will be that number? That number will be the coefficients of A, B, and C in the chemical reaction. So this is 3, this is 2, this is 4. How do you interpret this? The amount converted or reacted by A divided by 3 is equal to the amount reacted by B divided by 2 is equal to the amount of C produced divided by 4. So to add to this relationship, you have the relationship a while ago like this. This is fundamental for kinetics. These relationships that are derived from your stoichiometric equation. Whether the reaction is elementary or non-elementary, this relationship holds. The amount reacted or formed are related by the coefficients of the species that appear in your stoichiometric equation in the same way that the rates of reactions are also based on those same coefficients. Okay? Now, I'd like you to, I will now stop sharing. Do you have any questions so far? 2 minutes before my next class, do you have any question? Anyway, I have placed everything. I have placed everything in Canvas already. You start working on the things that you can work out already. You can work it out and don't submit it yet until I have reached the part in which will make things clear for you, because the problem sets that I've placed in there are already on the premise that I have discussed already. Everything that is included in the said problem set. So process them as we go along. Anyway, you have ample time to have them all processed. Read all the announcements there, and should you have any questions, just post it in the GC. That way, those that may have the same concerns as you will have it also addressed. Okay? Do you have any questions? So not tomorrow, on Wednesday and on Friday, that would be asynchronous. I suggest that you can study ahead if there's not much bulk of things for you to read, and you start working on what you can already work on. We don't see each other during asynchronous time, but you are supposed to work on the things that you are to work on during those time. I cannot promise that I will be able to make recordings again for the class. It depends on the demand on my time, especially now that enrollment was extended until Wednesday. And I think some of you can hear that my cell phone is been ringing and have been already texting me. A lot of students have been texting me with concerns regarding enrollment. So if I can find the time, I can record sample problems related to what we have discussed and the things that we are yet to discuss next week. But if you don't have time, please read on what is provided to you in Canvas. Okay? Any concerns, class? Because it's time for me to transfer to my calculus class. Any question? Okay, so I gather there are no more questions already. So I'll be hearing from you anytime this week. You can message me anytime as long as it's office hours, class. If it cannot really wait for tomorrow, then you can even message me during nighttime. Bye, class. Yes, Marcel?
Ang about ni bilang ni sa grado pala naman ni sa lightness.
Oo.
Scholarship.
Actually, tani hindi gid ko mag-message sa iya nga department chair kay weekend nag-observe gid ko sang Fridays man nga holidays ang nga week nga free day bla namon kaling hindi man lang kamo ang may concern, so nag-message gid ko sa Saturday. Actually your Sir Torres is not really well. So pero nakabalo ng iya nga DC nga wala siya kasubmit sang grade kag kinahanglan niya for your scholarship. Mahulat lang ko update either today or tomorrow kay kung hindi ako na lang marahatag anay certification regarding sa status ang grade niyo sa sina nga subject kay nang very ill na magina si Sir Torres wala pa nag-start ang COVID nga time mo. He's been going in and out of the hospital. So probably, hindi ko man makita guys sa personality nga hindi siya ka-submit grade on time. That concern na Marcel na ko na raise ko na sa DC niya, mahulat-hulat nang actually ang text man ni gani sa akong subong isa man naka-class nga may concern man sa grade sa iya. Wait until karon sa hapon, if not ma-wait ko until early tomorrow kay makuton ko na lang si Dean ko maubra regarding sa grades niya. Okay? Atong grades niya sa ang sa research niya nga grade nga INC, ako gini maobraya sang ako gini maobra sang certification kay hindi magid kamo ya marilisan sang grade kay wala pa ma-comply ang tanan nga requirements sa course mo.
Bali mes expected naman yung time bali buwas bagado settled na tanan naman yung
tani hindi ka mag-expect nga settled imo grade tomorrow March kay that's hindi na mo ya ang namin ko mahulat ko updates ng iya DC kay gina-contact mo siya sa iya DC mo. So saan nyo kinahanglan ang grade?
Mas possible tan mis kinara man kami bilang mis back up mis nga tag 2 weeks lang gihatag sa mo nga time para mag-prepare sa mga requirements.
Okay, as to my understanding, a classmate of yours told me that as long as the letter is given before the 28th of this month. Is that right? Pwede pa basta before 28. Kaya actually, ang mga DC, subong damo-damo, man na sila concern sa enrollment mo, kaya may mga estudyante nga pa-enroll, pati ginapa-insert, kinakayo ang schedule and all those things. So man ko magsagi bother siya DC, pero na-inform ko na siya sang Sabado pa. So follow up ko lang karon Marcel sa hapon. Kung wala pa gid siya may ma-update sa akon sa hapon, mag-message ko tomorrow morning, i-follow up ko naman siya. Pero nasulat ko na natanan ang concern regarding sa grade nga kinahanglan, may certification kamo sa inyo grade kung ano man na siya nga subject. Kung whether sa research na siya o kung sa light. Okay?
Okay, miss. Thank you.
Sige. Bye. Kaya I'm 4 minutes late in my other class already. Bye.